Okay, now it's restarted. That way we'll be able to break it up and give the first part and the second part. Yes, everything's going. Recording's going. We're seeing your screen.
Perfect. Thank you. So hi everyone. This is the project server box, and I do this project alone this semester. This is a new project starting this semester. It's an application engine for private servers, and it's based on Docker. I tried to develop this project because I got inspired by Kubernetes, Helm, and the Synology application store. There are the ways I get my ideas. So what is it? Imagine that we can get a private server, whether it's from DigitalOcean or AWS or Google Cloud. We always want to create our website, running our database server. We can do a lot of things with the server, but it can be very tricky and hard to install and configure the server environment and install the software. So that's why I create the server box. So the traditional ways to do this is try to find the official website and read the notes or the tutorials, install the prerequisite software, then install through the installation packages, whether it's in DEB, RPM, or compile from source code. Then we need to add the configuration files located randomly in the file system. Sometimes it's in etc, sometimes it's in user local or whatever. It's kind of be tricky to find. And then we can run the program or run the software we want. But how about if we want to do a backup or migration or upgrade? It may requires more effort to finish this. So with my project, we can just find the template of the software you want to install in the marketplace. Then you can just text whatever you want to configure as the configurable variables and click run. Then the software will be installed and start working. And also to do a backup, migration, or upgrade, we can always use the server box web panel to just click on the web panel to control the process of the steps. So it's kind of be easy. And now let's enter the demo because I'm very excited for this. Yeah, so, okay, the server is running. Let's go. So here is the application. As you can see, here is the marketplace, which contains a lot of templates, not much, just 4, because I forgot to add more templates here, but that's enough for demo. If you want to install the database in your server, you can just click the install here. Or if you want to run the Visual Studio Code server version on your own host, it's also easy to do this. For example, if I click the Redis server, you can see some basic information and you can configure something, but there is no configurable for Redis server. But for the storage, you can identify where to store the Redis server database storage files, such as if we want to save to like data, Redis, or something like that. But to make it easy, I just use Redis data. For the network, I can specify which port I want to run for the Redis database. For example, I want to set a random port number, and I want to call it my Redis DB and install. Okay, success. And now we can, oh, sorry. We can check. Here it is. Here it's running. The name is my Redis DB, and it's up like 10 seconds ago. And we can see this in the application menu. You can do start, stop, or see the details or delete. That's the progress I've retrieved so far. Okay, back to the slides. Okay, so the design of the software contains 4 parts. The first one is the applications. which means it's a application currently running on the server. We can create an application from a template, start, stop, restart, delete, all the actions you can do. You can also modify the config files, and also you can manage the files in the container through the web panel. The second part is a marketplace. If you have a marketplace, it's a collection of all the templates that you can install the applications. You can also add other community marketplaces. For example, if I'm a developer of a company, I can create my own marketplaces to store all the templates for my company products. And also, we can easily upgrade the templates. For snapshots, we can create backup and we can do migration. Oh, why I write transfer? We can do migration easily. To achieve this, we use the Docker dump. We can dump Docker images or containers to a par.gz file to achieve this. Also, I want to add a reverse proxy feature to bind the domain to a specific application, and also it can support HTTPS for secure connections. So for a template, a typical template contains 4 parts. The info part describes how what is the application, the information about the application, and it contains the environment variables that can be configured during installation, and it can specify the data, the location of where the data will be stored, and the network represents the port mapping for the application. So to create a template is also very easy. Here is the marketplace repository. You can see here a lot of YML, YAML files. If we see here, so this is the YAML file to create a template for Redis database. It follows the general parts. And if we go to the repository, we can see how to write a template and how to contribute. We can create the YAML file and running the verify and generate.py, then commit. If people want to add more templates to this repository or this marketplace, just make a new pull request and the things will be done. That's it. And let's go to the slides again. So for the technology, for core API service, I use Fast API because it uses the asynchronous feature in Python. It's very fast. I think it's faster than Django or Flask. And I use the SQLite for storing all the database or the configuration from server box itself. And I use SQL Alchemy to do the ORM, so I don't need to write a lot of SQL queries. Because I'm a DevOps engineer, I'm not very familiar with the front end. I don't know anything about HTML or CSS before I start this project. So I learned a lot of front end stuff. And it's very hard for me to learn this, especially the JavaScript. So I use React Bootstrap, and Axios for the front end. For the project management, I have 3 repositories. The first one is the core to store the core API server source code. Then the marketplace, the UI repository. I use MIT license, and all the contribution guidelines are written in the README file for each repository. Currently, there is only one contributor, which is myself. And for the progress, I finished a lot of things. I finished the draft design of the project. There is a draft UI, which is usable, but not very kind of fancy. And I also created the marketplace to store and share the templates. Here is the Open API format API endpoints here. Here are the APIs I finished in this project. For future, I want to improve the UI design. I want to use a better UI components, not Bootstrap, but like an end design or something like that. Also, I want to finish the scripts for installation or uninstallation. Also, the features of snapshots and reverse proxy should be done in the future. Also, I think the project can be used for enterprise uses. For quality assurance engineers, they have less knowledge about Docker or containers, so they may feel very easy to use my project to do some kind of testing in the company. Also, for the pre-sale technology support engineer, they can start a container or start a application easily and show to their clients. So that's the way I'm thinking about. So that's all for me. Any questions?
Do you have any questions for Mayu? So, um, so have you already the marketplace is how is that? You know, how have you decided to kind of use the marketplace? Are you are you standing up a website, or is it something that anybody can do, or what is the kind of the organization that goes into that?
Okay, so a marketplace is basically a GitHub repository. Um, It contains the YAML files as the template, for example, the MySQL file. And to build a marketplace, what you need is two scripts, which is the generate.py. This, this file will collect all the YAML files in this repository and generate a data.json. So my application will try to visit the data.json to get all the information in this marketplace. Okay. So that's the logic. So everyone can just contribute anything they want to add by starting a new pull request. That's easy.
Cool. Why don't you stop sharing your screen and we'll let ClusterDuck come up.
Okay, I'm going to stop sharing my screen.
Okay. Any more questions for
yeah,
Mayu while we're waiting for ClusterDuck to come up? Oh wow, ClusterDuck is fast.
Yeah.
All right. If you have any
questions, thank you very much.
Yeah, if you have any questions, please type them into the chat. Thank you very much. Excellent job. Wow. Now that's a background. I'm not hearing anything, but as soon as you're ready, we're ready to get going.
Can you hear me?
I'm hearing that, yes.
Oh, okay, great. All right, so our project this semester was working on the ClusterDuck protocol. Our members are myself and Olivia Davis. All right, so what is ClusterDuck? The ClusterDuck protocol was created to make firmware for Internet of Things electronic devices that utilize long-range radio, Bluetooth, and Wi-Fi. So these devices were originally created to be used as communication fallbacks in the case of primarily natural disasters. However, they can also be used by individuals or communities in areas of degraded or just simply poor connectivity. So the ClusterDuck protocol, shortened to the CDP, creates a network of ducts that range from sensor and data input ducts to network node ducts, final gateway ducts, etc. And they all lead up to one cloud network, which is referred to as the OWL.
All right, so ClusterDuck's focus has been on disaster relief, and it's designed so that people can access the network without having pre-downloaded software or any specific hardware. In the case of emergency situations, it's really good because you don't have to have an app to be able to send messages out. There's a link in the slide to ClusterDuck's GitHub, which has a more comprehensive overview of the network structure. But essentially, it's made up of different nodes, which are called ducts, and there's three main functions assigned to a mama duck, a papa duck, and a duck link. This is a good visual aid or representation for understanding how the network is set up. You have the duck link, which transmits data to the mama duck. The mama duck can transmit and receive data, and the papa duck collects all of the information. And from there, it either gets pushed to the cloud or it can be stored.
So there were a few blockers that we faced towards the beginning. and they ended up completely shifting how we approached our project. The initial proposal involved us contributing to the CDP's documentation, as well as addressing some of the lower level issues. It became apparent, however, that to address any of the issues, we had to first recreate them on our own network, which in other words meant that we needed to get the hardware. Long story short, through poor timing of the lockdown, it ended up taking about 3 weeks for the hardware to get to us. And by that time, we also saw that the documentation we had planned to do was already taken care of and just wasn't acknowledged yet in the issues page. On the bright side, this was also when we took an interest in the security side of the CDP. And with such a large network, it would be naive to think that no one would attempt to mess or manipulate with all the free data being sent back and forth. So we ended up changing our proposal to reflect this. And that brings us to research. So although Olivia and I were committed to working on the security side of things, neither of us actually had any network security experience. And that's where the research comes in. Instead of making actual commits, our RCOS contribution became assembling a quote-unquote master document with all the security-related research that we could conduct in order to understand the current progress that was being made with the CDP, as well as allow us to make contributions in the future. The compiled document not only serves as a reference for us and also proof of our work, but it can also be used by other newcomers to the project who'd like to start but aren't sure where. So just a quick clarifying note, Olivia and I both made individual documents. However, for the sake of brevity, and also since we largely focused on the same topics, we're going to be presenting them as one document. So here we have a brief overview of how we ended up conducting the research. We started with what was available on the CDP website, figuring out how all the ducts were connected to one another and how the hardware operated in complement to that network. We also made sure to detail how the data was being compressed and distributed so that later explanations of corrupted data made more sense.
Next became a comprehensive overview of network security. Paid special attention to the common adversary models and the known vulnerabilities that exist in stable aspects of the internet. Zero trust policies were briefly focused on because it's inherently practiced by the closed duct network, as well as mobile security overview because ClusterDuck recently expanded into an app.
So lastly, we went into the current encryption, which is the AES-CTR cipher, and the security protocol that the CDP employs. So additional research was made into known vulnerabilities, such as not adhering to the ESP, man-in-the-middle attacks with smaller bit keys for the cipher, cipher malleability, etc., as well as how those issues could be avoided.
Along with identifying vulnerabilities, field testing is a really good strategy for assessing what breaches the network. We looked into how we can contribute to the testing remotely, and we're at a point where we're looking into any tests that we could try on their network. A lot of vulnerabilities have been pointed out, but they're still in the fundamental stages of running tests and actually exploring the outcomes. So as we continue with the project, we are working towards finding new and effective ways for remote contribution. Documentation on vulnerabilities that have been pointed out is a good starting point. And we're also continuing to coordinate with those who are already working on ClusterDuck's network security. And our documentation and research will give us a really good starting point for when we come back to the project. Thank you for listening. Anybody have any questions?
So, well, let's first let's pop up the next group is Exalander. So maybe while we're talking, they can start getting themselves set up. So, how does your documentation fit into the overall project? Is this in a private repository, or are they putting it right in the ClusterDuck main? I mean, is this in your forks?
So it hasn't, at least it hasn't been put into my fork yet, but I'm assuming we're talking with Nick Fuhrer, who's in charge of the security stuff. So it's either just going to be shared through the Slack, newcomers go in and then they'll be like directed to a channel where they can access it, or they might put up a link to it in the actual GitHub. It hasn't been decided yet.
Okay, so I'm going to tell you that what I'm going to strongly recommend is that, you know, if you guys, you know, if they don't want to put it in the main repository, please fork the repository and add a documentation branch on yours so that we can see it within the repository. It'll make
All
it
right,
a lot
sounds
easier
good.
for us, and it's going to be more persistent and easier to do, because this is a good pivot, but we want to make sure that it's an actual public contribution, right? So if it's a Google Doc or something like that, those are very hard to find without the link. And if the link is buried somewhere in Slack, then you start getting, you know, you're getting touchy. I like the code should live as close to the documentation should live as close to the code and as close to the project as possible. So if it's not possible to get it into the main link, which is fine, you know, that they have their own project, they need to run it. Please make sure that it's in your repositories, in your forks, and then you can report it just like any other string of commits. Okay.
Yep, will do.
All right. Good pivot. Any other questions for? So have you? One thing
Why'd
that
you pick the name?
Right.
Like, yeah, why'd you pick the name Cluster Duck?
We actually didn't pick the name. It's under IBM Culture.
You
It's a
guys
pretty large project.
picked that name, or
so I think
so,
yeah, they didn't have the option of picking the name. It was an IBM project, but it was actually part of a previous call for code, and I think there's an obvious spoonerism embedded in there. I think it's called a
yeah,
spoonerism.
that's what I was wondering if that was why. Like,
Yeah.
yeah.
And I think that's probably intentional. It was developed by students or by young entrepreneurs. So,
Humor is great for coding.
yep. Yes, it is being recorded. All right. Do we have who is?
Here.
Please
That
share.
would be. Yeah, I can. Can people hear me first?
Yeah, we can hear you.
Great. Because last time nobody could.
Now everybody can, I believe.
That is great. So I'm gonna share my screen. I'm gonna hope that sharing Vine. Is it sharing all right?
It is starting to come up. It's not quite up yet. There you go.
Okay, great. Okay, there are so many things happening on my screen for some reason. God. WebEx is not letting me present. Okay. I'm going to ask again if people can see my screen. My computer's been very slow.
Yes, it says loading though.
Oh.
There you go.
If my screen is being really slow, I'll probably get another teammate to present. To do the slide part. Okay, so are we good?
You're good.
Okay, great. So I'm Sneha Ranjit. I am the project lead for Exalander. And so Exalander is a calendar website for all of your academic deadlines across all the classes that you might be in, works for both students and professors. So this semester we continued using JavaScript, HTML, CSS, and SQL. And the team, well, they're all on the slide. You will be introduced to all of them later on, so you can look forward to that. And team members we mostly had like specific web pages and server side of things, so that's kind of how this project kind of split. And for basically what we do, other than just the basic premise of the calendar aspect, we also want to make it that it is something that you can use in your personal calendars. You can put your own personal notes for all the events that are happening. You can see what's happening based on like for the week or for the month or like a day. And you can also have clubs, etc. part of it. And professors can very easily upload and edit the schedule of assignments. So everyone gets notified, so you don't have to like send them like 100 million emails or like a lot of notifications on different platforms. It's all in one place. And so for project organization, other than using Discord, we also have a really cool and updated wiki page, which is really cool. And we also started using the issue tracker this semester. The way that both of the project was kind of like divided amongst all the team members was like some of us kind of just picked out the issues that we found and we just worked on the ones that we liked. And then there was some collaboration between those on the server and on the website, like whoever was working on the front end on the website. There was some collaboration there as well because the project is finally further along that now we can start really focusing on how the server will connect to the actual website. So that was really cool. And we also, well, you have like links channel and stuff, so where people can just like put whatever things they found useful when they were like, well, dealing with issues that they found on the project. And moving on. So this semester, what did we get done? We got dark mode, which is something that people last semester said would be cool to have, so now we have that. In the actual calendar itself, my teammates will be going over this in more detail, but the rough view is we got a sidebar, we got notes, we got a way to make the months change with time, and so you can just like, click to go to the next month, that kind of thing. You will see that more in the demo. And we have professor page now, because now we're actually focusing on how professors can add things to the calendar. So now, right now, professors can just directly add events, and it will display them on their professor page. Again, you will see that in the demo. And in the server, we got login and sign up. Again, like fully kind of worked out and everything. And we're also connected to the database. So again, now whatever you put in through the professor's pages will be stored in our database and can be like, you can add and edit them or like remove them, anything like that. We also started working on CAS, and well, we're not fully prepared in that, like it's a work in progress, that kind of thing. But yeah, the process has started. And we also have a really cool wiki page, which I already talked about. And in the future, because there will be one, right now the calendar is kind of, well, a lot done. It just needs to display the events. We want to continue on with CAS for user authentication. We still have to like try to somehow connect it to people's personal calendars, and we still want to have a way for like professors, if they have like their slides and everything, I mean not slides, the schedule in like a specific document for them to like upload it, and then it'll automatically fill everything for them, which would be really cool. And also save a lot of time. And we also have, well, a mobile version would also be really cool to have, because right now this is only desktop website only. And since we started dark mode, we were thinking maybe people would like to customize how their calendar look. That would be really cool. And we also have a profile page, which is a little bit like a settings page where you just have, password changes and those kind of things. Like this is like see what classes you've got, those, housekeeping kind of things, I would say. Anyway, so team member contributions. We're starting off with me, Neha. So I worked mainly on the front end. So I worked on the events section in the calendar, which is like, well, again, you will see in the demo, but it's, I don't know if you can see my mouse, but the thing, oh God, that's the wrong slide. Yeah. So I also worked on a slide and a nav bar as well for a settings page. I also added like a grid for the calendar, because sometimes when you switch to different kind of views of days and months and everything, we're kind of merging together and becoming a mess. And then I also worked on dark mode, which is also shown over here. So, and then I also worked on login and sign up, where it went from this kind of plain white and blue screen to now this calendar as red and white screen. Okay, next up. Here.
Hi. Can you hear me?
Yes, go ahead.
Okay, just making sure. WebEx.
Yep, no good.
This semester, I continued to learn JavaScript, HTML, and CSS. I didn't really work on the front end as much, but I did create a login primary page, which kind of functions as like, like the main, like the first thing you see when you log in. It just gives you two basic like options, which is the RPI login link, which would send you to the CAS system, and if it was there, and normal login, which would lead to the old login page, which just says please enter your RPI email, where you can just enter any email really. We also discussed and created concepts with the team for the calendar page, and collaborated with the rest of my teammates to make minor visual fixes. We had some really weird scaling things that didn't look quite right that we had to get down. I also created documentation and wiki pages for the user. The user documentation has basic features, tutorials, and information. It kind of functions like a Q&A, how to get things done, and also explains features, which are mostly not currently implemented, but are described as they would appear, have they been implemented. So it makes it easier for our developers to create a feature. We can look at the wiki and be like, okay, what do we want our users to be able to do? I also started a documentation branch with screenshots of the current websites, so I can keep track of how the websites currently look and describe the features that currently appear on the page and how they've changed. So if we ever want to go back, we can have that instead of having to guess what things used to do. The aim is to have a record in case we want to revert to a look or a function, and the documentation gives a brief explanation of the current functions and its interactability.
Hi guys, my name is Nicholas Yao, and in terms of contributions this semester, I worked mostly on the back end regarding SQL and SQLize, our ORM. I built a lot of the REST API calls that we'll use from the website side of things, including the ability to add events, delete events, logging in, signing up, etc. This is great because now if you're looking at your calendar, you'd be able to then actually get this information. This is currently being used in the professor page. We have a very simple set of forms that lets you actually add events and display those events. And on top of that, I also worked on a lot of documentation since it was pretty bare bones at the beginning, which includes things like contributor guidelines for newcomers.
Hello, everyone. My name is Yao Moasari, and I helped Nick out with setting up the SQL database. So I hosted a database online on a website called freedb.tech with plans to permanently transfer it to AWS. I also helped connect the database to the front end via REST calls. And I also started creating query that allows for recurring events to easily be added to the database. And then I also documented instructions on how to set up the database for future users.
Hey everyone, my name is Samyut. This is my first semester in RCOS, and so this semester I kind of mainly focus on the front end and familiarize myself with some more CSS and JavaScript features, as well as learning source control and how to contribute in GitHub and those kinds of things. And I worked almost exclusively on the calendar this semester, so I fixed some bugs with the display, such as some of the header, for example, being static as you scroll down, and visual fixes like those, or the days not wrapping properly. And I also built functionality for the calendar, so you can actually scroll through the months using the next and previous arrows, as well as adjusting the header to keep track of the months as you went through, and also weekly and daily views, as well as the implementation for dark mode.
Hi everyone, my name's Harshita, and I'm also new to RCOS this semester. I worked on the front end for the main calendar page that you can see up top, and mainly all I did for the calendar was I reformatted the buttons to the left, and I did minor CSS fixes so that the week wouldn't get cut off in the event of a 6-week month. I also created the footer and the sidebar functionality that you saw before, as well as the add event button on the main calendar page. We also have professor pages, which is brand new this semester, as we mentioned previously, and I created the HTML elements that you can see to display the classes, as well as edit the classes, as well as the JavaScript necessary to create the elements based on whatever info you pull from the database.
Not okay. My slides seem to have okay. Sorry about that, technical difficulties.
Hello, everybody. My name's Ellie. I'm yet another first semester ARCOS member. I mostly worked on the SQL database along with Nicholas and Ya. What I did was updating the database diagram and table relationships from last semester. But for those of you who don't know, a database diagram is just a visual representation of how data is related to each other. So mostly I helped visualize the distinction between student users and teachers. Originally we had just a teacher ID associated with each class, but then we decided we might want to give students the ability to add events. So we ended up with a table for user IDs that were also class admins. I also fleshed out the events table to include more like things such as titles, dates, and descriptions. And I also helped create issue tracking for adding, updating, and removing events.
Hello, my name is Tenchi Nagashi. This is my first semester working on RCOS, and I researched ways to implement RPI casts for student information gathering. The idea is that with one simple RPI login, we will have access to the student's name, major, and classes. I started implementation on this idea using a web framework to set up passports for authentication and a router for function control. Although the implementation was not complete, I also found previous RCOS projects that utilize this integration. Using these previous projects as reference can help us further develop this concept in the future.
Okay, so for a demo, which I'm gonna go through as quickly as I can since we're out of time. So, okay, so we got this is kind of the main calendar page thing. So we got like these little tabs here, so you can switch different views. This is not a live demo, so we've only got screenshots. Sorry about that. Yeah, so we got like little tabs, so you can switch views, and you also got dark mode to on the moon sign thing. Anyway, so we also have kind of like a little button up top here, which will, if you click, will let you add an event directly to the calendar. For now, it's just stored in the database. It doesn't get printed out yet, but it is there. And then this is the professor pages where like you can see all the classes that they're in, that the professor can like is teaching, and then all of the events, exams, homework, etc. that they have. And this is also how you like, you know, make the event. Anyway, so we have, well, this is the kind of two login things that Kira was talking about, where this is one is your RPI email, and this is the other one where you like get to click them to like, well, get to the login page. And that's kind of basically it for our presentation. So does anybody have any questions or concerns or anything they want to tell us? Also, we thought it was important that we have something like this in this, so that's why we now have this in our slide. Which my computer is taking 3 times too. Okay, I'm gonna stop sharing now. Anybody?
Sorry about that. I was muted. So let's get Discord Scriptbot up. And does anybody have any questions for? Oh, never mind. We've got some questions going on. DBIO. Cool. And if let's in the thought of preserving time, if we have any more questions for Exalander. Oh, one quick one. When are you guys going to be releasing a minimum viable product publicly?
Maybe the next semester.
Awesome.
Not this semester, but maybe next semester we start talking about like actual proper deployments and all those kind of things.
You know, it's important to get these things out at some point because it's easy to keep doing more and more without ever releasing. So it's good to get to that release point. All right.
The plan is there.
Good.
Thank you.
Discord Scriptbot, you're up.
Hello. So this is Discord Scriptbot. The name is tentative. I just haven't come up with a good one yet. So this bot has no features built in. Everything you want it to do is completely defined by you. And we'll get into how that works. So for teammates, I'm the only one currently. If you'd like to join, I'd love to welcome new contributors. Just reach out and I can get you set up with the project and add you to the repository and get you set up with everything you need. I'm also currently working on documentation to make it as easy as possible for new people to join. So this project is about developing a fully scriptable Discord bot where you create scripts right inside of Discord with no real coding required. Everything is fully customizable. Nothing happens without you giving the bot specific direction to do certain things. The project aims to eventually be the most customizable Discord bot available as an alternative to popular bots like Dino and Me6. For the development stack, we've got C#, .NET Core 3.1, and Discord.NET for the Discord library. You can see an example script here, or a bunch of example scripts actually. Not all of these currently are supported, but they will be very soon. So for organization, I used Trello for a to-do list and for keeping track of everything that is currently being worked on. And I'm planning to create a GitHub wiki for new contributors to learn everything, like I said earlier. And the project uses an MIT license. And for actual code, like actual development stuff for features in progress, I use GitHub issues for discussion, like a discussion forum. And now we're going to get into a demo. You can see how it works. I'm just going to commentate over a couple of videos going over 2 scripts being created here. For the first script here, going to create a guess the phrase game. And so currently, message received is the currently only event supported. So you can see what the event has. Every event has parameters, basically, which is a message and text channel in this case. So we're creating a new script called demo1, and it's going to be ran on this message received event here. And now I'm just showing the message object so you can see what we can do with it. We can delete it, and there's some test things. Here's a string which wraps the text for the message. And now we're actually writing the script. So we're doing an if the message contains super secret, then we're going to send a reply to the same channel the message was received in, which says you found the secret. And then we're doing an else to say when you didn't guess correctly. And all these commands are still a work in progress, so they may be changed later. This is currently how it works. So now I do end to end the if statement. You don't have to do that. If you're done with the script, you can just do /done. And done enable just finishes the script and enables it right away. So now we're going to test it out. And we see that the script is enabled. And we can show the details of each script as well. And we're testing a script, and that wasn't the right word, so it says try again. And that's not it either. It's case sensitive. And with capital S, that matches. So that is the most basic script. All right. And then demo 2. This is a lot more complicated. Basically, it will, first of all, we have demo 1 still running, so we're going to disable that first. You can have multiple scripts running at once, of course. So yeah, the new script we're going to create here is a lot more complicated. It's going to have an and or an or, and we're going to delete messages that we consider bad. So first we're going to lowercase the text string so it's case insensitive, and then we're going to check if the text contains one of our bad words, which we're going to say is hello, and then or if the text contains hi, then you can see you don't have to put it, then for if. If you don't put a then that the bot thinks you're going to do some more stuff like or and. And then when you do then is when it enters basically the code body. So now we're going to delete that message if it matches, and then we're going to send a reply to the my channel. Here's another thing. You can see we're specifying my channel. So it's going to send specifically to my channel in the server that the script is running in. And then, so it deletes the message and then sends bad message to the my channel. And then else, we can also use the ID of the channel as an alternative to the name if we want. And then we're going to send text saying good message. And now we're going to done and enable it. All right, so now we're going to test it. Okay, so our message contained hello, and it deleted it and said bad message. That's good, and it works. doesn't delete. All right. So, yep. That's good. And what is happening? There we go. All right. So here's an example of a script that has been saved. This is the demo 1 script that we created in the first video. Please don't write these. You're not meant to write them manually like this. All the scripts are built directly in Discord. So yeah, it uses YAML for the actual serialization format just so it's fairly readable. And so prior to this semester, the project was started this semester. And this semester so far, I've got script building via commands, script serialization for loading and saving, and script execution, as well as basic commands like enabling and disabling, listing scripts, and listing APIs like string and message and all that stuff, so you know what the bot supports. Also started documentation in the code and on GitHub. So future work, there's a lot to do. This is only a small subset of things, but the first thing I want to do is integrate with Discord's new /commands feature, which basically allows you to send the your bot commands to Discord, and so whenever anyone does /, it'll show you everything the bot can do. But Discord.net, the library I'm using, doesn't currently support it. The next thing is script scheduling, where you can run scripts at an interval or during certain days or times that don't actually rely on an event. So you can just, like, for example, go through the list of users and check names or do whatever you want. Also, script prioritization. So if you have 2 scripts that run the same event, they will run in some random order. And so being able to prioritize them may be useful. Also want to support external plugins for platforms like Twitter. For example, if a tweet is posted, then that could run a Discord event to post a message in the channel. Also want a better command scripting interface. The one that I have now is kind of a prototype. Doesn't work the best. It's kind of a little weird. And also got to wrap more Discord features because currently we only have message support. And of course, refactoring. There's a lot of code cleanup that could be done. Any questions?
Nicely done. So this is something that we can. Does it need to be installed into the Discord, and does it need to be installed on at the server level?
You have to run. What do you mean? It's currently designed to run for one server at a time. It does support multiple servers, but it's not meant for that. So you'd have to run it on a server.
Okay.
You can't just install it
Okay. I think Frank has a question too. Any plans for a different UI option to make scripts?
Yeah. I was considering a web interface and also like a basic React-based interface. Still have a bunch of experimenting to do with that, but yeah, definitely.
Almost looks like a Blockly would be good.
Looks like a what?
Like if you were to use the Blockly format with the little blocks that hook together. I don't know. Just looks kind of
yeah.
Nice. Very nice.
All right, let's stop sharing.
All right. Where does it move us to? Venue.
Venue, yes.
All right, can you guys hear me?
Yes.
Okay, perfect. So hello, my name is Daniel Dukeshire, and today I'm going to be discussing Venue alongside group member Thomas Durkin. We will talk a little bit about project features, the scope of Venue, as well as our semester progress. Our group consists of Thomas and I, as well as our project lead Ethan and Trevor Bisson. So what is Venue? If you've been attending lectures, you may know Venue as a classroom management tool that integrates QR code-based attendance while enforcing asynchronous lecture recording playback. So here an instructor can sign on, create courses plus group events. So with this, students can join these created courses in groups via shared email request and verify classroom attendance for a lecture or meeting upon a screen shared QR code. So as you may have noticed here, our name is slightly changed. This comes with a completely new UI, backend redesign, some technology changes, and a brand new ticket system. In an effort to be scalable, to be a scalable learning environment and management system, we have also begun to incorporate some new features and functionalities.
Our project uses the Maven stack, which consists of MongoDB, Express, Vue, and Node. We use MongoDB for our database, and to interact with the database, we're using GraphQL. GraphQL is an open source querying language, which lets the client specify the exact data needed, so there's no underfetching or overfetching of data. Our backend consists of Express and Node, and for our front end, we're using Vue along with the Quasar framework, which gives us access to components to use and build our interface.
So how do we stay organized? We follow the blessed repository system, integrated workflow model. So new changes are staged and pushed to branches that correspond to specific features of the project and are merged to main by the project lead upon successful code review. Contributors must follow our community guidelines, documenting proper behavior for a positive workflow and open source environment. Members stay updated via Discord, where issues and topics are grouped by bugs, backend, front-end, infrastructure, and general development discussion. Members are encouraged to actively check the Discord for blockers and pressing topics. And on top of this, members are also encouraged to document their work in an effective manner, whether it's writing a strong commit message, keeping changes as focused as possible, or informing collaborators of issues and bugs.
So our progress so far for this semester is we have new QR code functionality. We have a ticket system, so each person in attendance will have their own QR code. And you can see a little GIF in the bottom left of what's happening. As the seat is claimed, the QR code will change. We tested this functionality during one class on our deployment server, and the test went pretty well. We also have an email notification system, which has been implemented. When you first create an account, you receive an email to verify you have entered the correct email, along with a link to continue creating your account. You also receive an email when you have been added to a specific course. We have added a lot of documentation this semester as well. There's a well-documented README to get new developers up to speed, as well as some contribution guidelines. A user-friendly calendar has been added to the dashboard, which will display upcoming or past lectures or assignments. And we are in the process of finishing up the new UI.
So I'm going to talk about my contribution specifically. So as stated before, a lot of our work this semester went into an email notification system. But before jumping into that, however, this was my first semester in RCOS. So I had to learn the technology and stack. I didn't really have any full stack development experience before this. So this took me a little bit longer than expected. But over the course of my time following tutorials in Vue, GraphQL, and JavaScript, I compiled my learning sources into documentation for future new devs and contributors. This included a new README for project startup, contribution guidelines, as well as a Maven startup guide. So after that, I then began working on the email notification system. In the past, students could join Venue by code or link access. This semester, we kind of sought to change that with an email system where the instructor would share access to a course or event via an email. On top of that, the system requires an email confirmation upon Venue sign up, as Tom said before. So with this, Tom and I worked on integrating a Gmail address through the Node Mailer framework. A lot of this was Gmail troubleshooting and integration testing, as well as CSS and HTML styling. We wanted to maintain that Venue theme with the new UI, which brought the use of handlebars. So handlebar files are allowed for the reading of HTML files into JavaScript while being able to pass variable objects into the HTML source code.
You can see an example of an email you will get in the bottom left. So for my contributions, I previously worked on Venue, so I knew most of the technology used. Since we have changed from RESTful API to GraphQL, I had to spend some time learning how GraphQL was integrated with what we already had. Once I had a complete understanding of how GraphQL worked, I began working on the course page. I added something simple to the page, such as a course title and description. Then I moved on to something more complex, the share button. This will allow instructors to share that course with students. I created a form with the shared user's email as well as the role you would like to assign them to. At the bottom of the form, you can also view who has already been assigned, already been added to the course and what their role is. I added backend functionality for this as well, so we could get a working email system. I also assisted Dan with his work since it was his first time working on Venue and using these technologies. And there's a GIF on the screen showing how the share button works.
So some future goals. Unfortunately, Tom and I are both seniors, but these are kind of what we want to see for the project. So the future of the project is to hopefully further development to a full learning management system. This includes implementing assignables, as in homeworks and gradables, as well as a calendar system for lectures and such assignments. This would require an entire rework of the UI and internal data flow. On top of this, a less important goal is to interact with the WebEx API for a more seamless QR code experience.
That's all for our presentation. Thank you for listening and thank you for using Venue this past semester. So I saw a question why Quasar. I did not have a decision that our project lead decided to use that, so we just went with that.
Gotcha. Just looked up. Looks pretty cool.
Yeah,
Okay.
that's pretty nice.
Thank you, Venue. Next up is social. So Venue, if you could. Oh, thank you. Social, go ahead. Okay,
All
we
right, can you guys see
your
that?
screen. Yep.
Yep. Present.
Everything looks good.
All right. So we are social. The members in our social in this project is Kong, Tiffany, Suhan, Brian, Aiden, and Jackie. So what is social? So a high-level description of social is basically that it is a web application that helps users really communicate and expand their social circles, mainly using mini games. So social is a new external project to RCOS. There's 7 parts, but for the sake of time, we'll focus on the 2 that we're really working on in RCOS. So the first part is the user feedback forms, as well as the mini games that help users interact and build friendships.
So for organization, all of us were invited to UA's Git repository for the social project. And the 2 main tasks that we had were the survey and the mini games. For the survey, Suhan was in charge of it. And for the rest of us, we were in the mini games. And we each made our own branch in the repository. So we committed our own work to our own branches. And for the mini games team, in the beginning, all of us used a template that the project leads gave us to put down our game design and our ideas, and they had to be approved by Tiffany, one of our group leaders. Every Tuesday, it was our work session, and every Friday, it was our status update, where we just give a brief Google slide presentation about all of the work we've done for the week. Next slide.
All right. So my name is Suhan, and my task for this semester was working on the reporting form. So just quite straightforward. It's a reporting form that covers BART, Title IX, as well as our own custom social reporting form. So for BART or Title IX, it would go directly to RPI, whereas for the smaller issues, smaller reports, it would go directly to us. You can see on the top right how our form works. So I mainly worked on front end as well as routing for the form. So the form also directs users to the right reporting form fit for them. And also it's done in React CSS as well as HTML.
And as Brian said, we are designing and creating minigames from scratch. Next. And we are using Unity as the engine for the games, and Mirror, which is a high-level networking library to implement the multiplayer feature. Next. The game I'm working on is the treasure hunt, which its goal is to find a hidden object in the map. Next. And this is the lobby screen of my game. Player could identify themselves in this stage, and the game supports 2 to 5 player. So if this limit is not satisfied, the game cannot be started. So as you can see on the bottom right page, on the bottom right picture, the start button is deactive. And the lobby is the leader-based system. So the first person who joins is the leader, and he will host the game and has the ability to start the game. And the player could also toggle the ready status in the lobby. And once everyone is ready, the game is starting. Next. And there are two roles in the games. One is the finder, and the other one is the guide. The finder is the one to find the hidden object. And they have magical wands that could shoot out orbs to the hidden object. And they have basic movement, which are walk and jump. And they also have a chat to communicate. And the guide, as you could see, is invisible, so the finders could not see them. They are the leader of the lobby room, and his function is to guide the finders, and he has the ability to control the lights in the map. And at the beginning of the game, he will be spawned next to the hidden object and knows what kind of object that hidden one is, and he could fly and moving around. Next. And this is the map of the game. As you could see on the left side of the slides, that is the light that guide used to communicate with the finders. Yeah, the guide could see the finder's text channel, but he could not type anything in it. Next. And those are the game views of the guide and finders. As you can see on the left side is the guide, and on the right side is the finder with shooting orbs at the ground. And some obstacles in the games when I am dealing with the mirror package about the networking. And that is my game, Treasure Hunt.
All right, I'm Brian, and this is my game, Strive Time. Next. So this is a competitive team-based racing game, and the way it works is that there's a maximum of 8 players, and they are split into 2 different teams. One is called Defenders, and the other is called Sabotagers. The way it works is that each team has their own cart. The one on the left is the Defender, the one on the right is the Sabotager, and in each team, one player is designated as the driver, and all the other players in the team, they stay on the back of the cart, and they have their own specific actions depending on what team they're on. So for Defenders, their main goal is to reach the finish line, and their specific action is that they can use a shield to block incoming obstacles. And for Sabotagers, their job is to knock all of the Defenders off of the stage. And they have the ability to shoot projectiles at them that can push the Defender carts if they don't have their shield up. And all of the players on the back of the cart, they can switch positions so that they can have a tactical advantage while on the level. Next. So the lobby system is similar to Jackie's. It's leader-based, and all the players have to ready up, and the leader's in charge of starting the game when everyone else is ready. Next. So this is what the game looks like. As you can see that there's an obstacle course in front of the finish line for the Defenders. The Defender cart has to cross the obstacle course in order to reach the finish line. And as you can see, the Defenders can put up a shield to block projectiles. There's a third-person camera. The main obstacles I encountered while doing the project was fine-tuning the driving and making sure the third-person camera works for all players in multiplayer. And in the future, I hope to implement the switching player system. Next.
Hi, I'm Aiden Sullivan, and I created Danger Save the World. And on the next slide, we can start getting into what that is. Danger Save the World is a 4-player cooperative multiplayer job completion game where players are racing against a time limit in order to complete all their tasks that they're assigned at the start of the game. All these tasks require players to actually interact with each other and talk to each other in order to gather information that they need to complete their tasks. So on the next slide here, we can start to see kind of some of these foundation level tasks that are available that generate information for the players. On the left is a task that requires keyboard input where a player will answer these two questions. On the right is just a button that they can click and then walk away and eventually come back to get this code part that they'll eventually need for another task. On the next slide here, we can see kind of how this builds up a little bit more, where 3 players will have completed this data input task, which will grab their little cube player color and put it at the bottom here, which will then need to be connected to all their different names, which is in the middle, and then their names to their majors. On the next slide, we can see a little bit more functionality from this, where you can remove these wires, and there's error checking involved to make sure that you're not randomly placing these wires about, and it's only where they're intended to go. On the next slide, we can see a little bit more to give you a better idea of what this game's about, where 2 of these decrypt buttons generated codes, and then these codes are used in this keypad task, where they'll be randomly appended together as displayed by the 2 pips, where the one on the left is the code that comes first, and the one on the right is the code that comes second. So for instance, what you can see here is that the green code needs to be put in first, followed by the gold code, and that will complete the task. Whereas if you do it in the reverse order, it'll pop up incorrect and then not work. So the last task that we're going to kind of show to further give an understanding, and in addition to what the map is the sync button that's used to start and end the game. So all the players need to click and hold this button, which when they do so at the start of the game will remove the red barriers and start the timer. Whereas at the end of the game, once they've completed all their tasks, they can come back here, hold this button down, and then that will complete the game and win. Finally, I can show you off on this next slide, kind of a overview of what I wanted to do across the semester. Everything in green is stuff that I completed. Everything in pink is stuff that's kind of a work in progress. The red line indicates where I wanted to be by the end of the semester, but as you can see, it's not totally full. I attribute this mostly just to me not having a full understanding of how much effort would be needed to complete these things, because I'm new to RCOS, as with all of our other members. And we have a huge idea of how much effort this would take. So you can see eventually we wanted the procedural map generation. I did everything with that in mind. And with that, on the next slide, that kind of concludes our presentation. And we can open up to questions if we have time. Thank you for listening.
Thank you. Welcome to RCOS, all new members, and that's a lot of progress across all those games, so and the non-games, so awesome work. If there are any other questions from anyone, feel free to drop them in the chat. So keep an eye on the chat for anything else. And next up is Submitty.
All right, yeah, I'll just be sharing my screen.
Sure.
All right, so can everyone see my screen okay?
Yes.
All right, great. So yeah, we are Submitty. I guess we can just go down and introduce ourselves. Kevin, you want to introduce yourself real quick?
Hello, I'm Kevin Kagani.
I'm Jensen Lee.
I'm Roland Rao.
And I am Vikram Shrikishan. Okay. So Submitty has a whole bunch of features. We have a programming assignment submission system, which most of you have probably used. Submitty has customizable automated grading, an interface for TA manual grading, and off-hour/lab queue, which is especially helpful now in our online environment. We have a discussion forum, brand new Submitty polls, which is our polling system. And it's really great for specifically used in data structures and some other classes as well. So it's really cool there. We've also made some additions to aid with remote instruction and the transition to completely online classes. And finally, we do have plagiarism detection. So we are, of course, open source. Our tech stack in Submitty is PHP, Postgres, Twig, Python, C++, and GitHub. And we're actually no longer using Travis for continuous integration. We actually moved to GitHub Actions. Big thanks to Shale for that one. And for work within the Submitty organization, we have issue trackers, so kind of labels for different issues. And we also have feature branches. So for onboarding, we try to make it as easy as possible for new developers to contribute to Submiti. As I mentioned before, we do have issue trackers, so we have good first issue labels, which are put on some issues that perhaps wouldn't be as involved or would just be in general good for developers to learn more about the Submiti code base. And all of our issues and the feature requests are available directly on the GitHub site, so anyone has access to that. And we also have Submiti.org, which is our documentation website. And here we have the documentation is kept up to date pretty often, and it kind of has instructions for how to install Submiti locally, get it up and running with your virtual machine on your computer. And there's also a how to contribute section, which is really helpful for new developers. It kind of allows them to learn more about Submiti and learn how to make pull requests, learn how to review other pull requests, coding style, and more things like that, which just makes it that much easier to for new developers to contribute to Submiti, because with a code base as large as Submiti, it could be intimidating. So that kind of just helps out. And I should know, I just joined Submiti last semester. So now we're going to move on to our individual contributions.
Starting with me. All right. So I worked on this semester. I am a first semester ARCO student. So what I worked on went into the realms of TA grading and also peer grading. Now, a lot of students probably haven't seen the menus on the right of the screen. This is the grading interface and how you would grade an assignment. TAs have seen these, instructors have seen these, and now students can. On the bottom right, you see the purple block indicating a peer gradable component instead of a non-peer component. Now, there are also, among the options that you can pick in terms of between full credit and no credit for an assignment, there's also a custom mark option. I removed this from the peer gradables because students shouldn't be able to pick a custom mark for grading other students. This also came along with a little pop-up message that you see in the top, bottom left there. Are you sure you want to delete the custom mark? This has given Submiti trouble a couple semesters ago, and it occasionally crops up, so that was a bug fix as well. And there are plans to actually suppress the custom mark option for an entire gradable, or even for a course, because maybe an instructor only wants their TAs to submit exactly in accordance to the rubric, which is fair enough. So that's going to be an option coming up soon. I also worked on, and this is something I'm still working on, but more browser-specific options. There are some settings that are having issues on Firefox specifically. I'm looking into those.
I work primarily on the TA grading side of things. So I added in notebook file submission rendering for file submissions in the notebook on the student side and on the TA side. And I added a variety of random TA grading features like 4-panel TA grading and component wraparound, and fixed bugs in just like a bunch of random places. And I also wrote up documentation for debugging a development environment of Submiti on remote devices.
Hi, so this is my first semester in RCOS, and one of the, in addition to some bug fixes and CSS, tweaks, I was working primarily for most of the semester on something called the Student Activity Dashboard. This is a fully new feature this semester, and it's for instructors only. And it's basically for instructors to be able to assess whether or not their students are coming to class. As you can see here, there's about 6 text fields here. They're all date fields. And basically what you can do is, as an instructor, you can limit it to say that I want to see all the students who haven't posted on the forum since the 21st of May 2018. That was just like an example date. So I put that in the forum post date. I hit the apply button, and then it highlights in red all the students who haven't posted on the forum since then and sorts them to the top. So basically what we wanted to do is, because of COVID and virtual learning, this is the easiest way for teachers with large classes to take attendance. So we want this feature to be available to the professors for next semester in case we are continuing to be online. But yeah, this feature was requested by some professors, and I spent most of the semester working on this. Yeah, it basically just pulls a bunch of data from the database, dates on when people last accessed the gradable page, submitted a gradable, viewed the forum, posted to the forum, number of poll responses, and last time they were in the office hours queue. And based on any combination of any of those 6 fields, instructors can limit and refine their search for as to who's not participating. An additional feature was the ability to download the entire list as a CSV, and there is a hidden column off the end that says whether or not the student is flagged, because obviously we can't represent colors in a CSV. So yeah, that's what I've done this semester.
All right, and my main work in Submini this semester was on adding something called subsections, which are basically so each each person in a class, so each student in a class has their unique, not unique, but they have registration sections, and this is kind of like a mandatory thing to organize students. So this is kind of the registration subsections, which are used to organize students more and help out with grading and other things, other course management related things. So the main use for this was an implementation for labs. If you're a mentor for data structures this semester, you've definitely seen these subsections being used. It kind of helps for allows you to see which students are in which lab section, and allows you, rather than having to control F where they are in the whole big long list of students, you could just go to the lab section and see everyone in that section right there. So you can see on the bottom right, everyone's sorted by their lab. It doesn't have to be lab 1. It can be anything. It'll just be sorted alphabetically with everyone kind of next to each other. And then above that, you can see some sorting options. So it's kind of I kind of condensed all of the different sorting options into a drop down, which kind of makes it easier. Everything's in one place. And you can see how you can sort it. So for example, in this example, it's sorted by section, then subsection, then the user ID. So all these people are in section 1, and then they're in the subsection, and then they have the corresponding subsection, which kind of just makes it easier, like I said, for grading. And at the very top, that is how the registration subsections are being set in just a text box right there. And then subsection for implementations for other gradables, such as the maybe like test grading or homework grading. That's a work in progress. That'll be done soon. And I also reviewed some PRs and looked into minor bugs around the Submini system. And lastly, we just wanted to say a big thank you to Professor Cutler for kind of just leading us and helping us out with everything and being a great mentor for the Submini contributors and the whole Submini team. All right.
Thank you.
And that is all.
Great. And it looks like we are a little ahead of time, so that's great. If there are any questions, feel free to ask. I have 1 or 2. Well, first, it looks like y'all had a lot of progress this semester. Kind of almost unrelated. I'm just curious, who manages the themes of like the duck logo and also like the confetti on the gradables page? That's always something to work on.
The confetti, I believe, was actually Shale, who looks like we have right here in the chat. But I think, yeah, I'm pretty sure Shale included the Submini. It's a little, if you get 100 on your whatever homework or something, then you get the confetti. So it's an incentive. That's the only reason I try to get hundreds anymore. Just so I can see that Submini, just so I can see the confetti. But yeah, and then yeah, as Professor Cutler said in the chat, that was done by one of the contributors. Just so those are where we get the Submini ducks.
Awesome. Very cool. Thank you, Submini. And again, if anyone else has any other questions for Submini, feel free to ask them in the chat. Anytime. Go ahead, stop sharing. And last but not least is legit info.
Okay, let me share my screen. Can you guys hear me?
Yes.
Sweet. Okay. See this?
All good.
Cool. All right. So I worked on the IBM Call for Code project, Legit Info. It was just me that worked on it. No other students joined me for this one. So Legit Info is a platform that packages up legislation from different areas in the country, and it kind of gives them quick summaries so you can search up in your area. So it takes in legislation from this big database known as Legiscan that has like the full PDF documents for bills that are being created, and then it uses natural language understanding and creates little summaries and places them in a database that you can search up very easily. The repo's linked here. I link it later as well. Uses the Apache Sioux license, and it's open source, obviously. It's mostly done using Django and Python, although there's some basic front end stuff with HTML, CSS, JavaScript. It uses SQL for its databases, and it uses IBM's Watson Natural Language Understanding, which is a private product, but because it's an IBM project, you're allowed to use it in the basis of this project. So if you're to use this Watson product, you'd have to pay for it, but because it's in their own project, they allow it. And they have a developer tutorial linked here. It just has basic setup and a basic summary of what the project is. The group mostly discusses changes in their Slack. IBM has a giant Slack for all their call for code projects. It's mostly worked on by IBM employees, and there are a few outside developers. I think for this specific project, I'm the only person who's not an active software developer at some company. Mostly IBM. I think there were a few people from American Airlines that worked on it. And there's some regulations for contributions in a markdown file that's linked on the main repo. And they like you to do work through pull requests so they can bring in outside contributors more easily to this larger project. So like I said, it takes in these PDF documents here from Legiscan. It has them downloaded and automated en masse. And then it has a large amount of code that's just for extracting the PDFs into text documents and running this Watson language understanding to create an auto-generated little summary. So it's a little more digestible, especially in a search client. And then it places all these summaries in a database with a location that the legislation is from. So this location can be an entire state, just a county, a city, the entire country, things like that. They're all kind of given their own IDs in the database. And they're given categories such as healthcare. I'll talk more about that. But yeah, then it allows with a nice website interface to search and query up these laws. So like I said, they're all able to be queried with a location and an impact area. So it can be a country, a state, a county, or a city. Obviously, this depends on where they pulled this PDF document from. So you can do, like I said, United States, Arizona, Maricopa County, or Glendale, Arizona. They all have different pieces of legislation. So something that impacts the entire state will go specifically to the Arizona section rather than going to Glendale and every other city. It will all be in Arizona, things like that. And then there's healthcare, safety, environment, transportation, and jobs are the valid categories that it allows to be stored under. There's a small user system. It's a bit bare bones, but essentially you can register on your local segment. I don't think there's a live website, so it's mostly just for testing currently. But you can create a username and a password, and then with this password, you can save your preferences for what areas you want to look up legislation in. This semester, I mostly did work on the search function. I'll show you that in a second, but it was a little clunky. It uses this giant single drop-down menu with like these branching L-shaped things for locations. So I'll show that. But I created a new set of drop-down boxes that allows it to filter down a little easier. I added hyperlinks to the original PDFs from Legiscan to the summaries that points back. And I had to work on a bit of the contributor documentation because, like I said, I think I'm the only person to ever work on the project that isn't a active software developer, mostly in IBM. So it was a bit lacking in resources for new contributors. There were things like good first issues, but not necessarily very good documentation on how to start it. Here's the search function before and after. Before, it had this single location dropdown, and it looks presentable in smaller amounts, but as soon as you add more states, more cities, this would just be scrolling endlessly. So I created these dropdowns that take from the branch above them to make it a little easier to digest. And then I added these links. Here it's listed with source none because I loaded this set of laws from a already created JSON file without links. So if you were to actually automate and run the Watson understanding on a PDF document, it would have its original source to the Legiscan page it came from. And yeah, I've put in some work into rewriting a lot of the getting started things. Many of the commands are outdated. If you do things exactly as they say, it just doesn't work anymore. So a lot of it needs to be redone for people like me to come back later. And yeah, it's still relatively early. I don't think they have database seeding for states other than Arizona and Ohio currently. So a lot of the changes I proposed about scaling aren't even really testable yet. They don't really have databases set up for all those things, but that's a lot of the work you need to do is get a live website going and get larger databases going. That's it.
Awesome. Thank you. If anyone has any questions, feel free to ask them right now in the chat or mute. I have a question myself. So that's pretty cool. That, I mean, working on a major IBM project, so you mentioned there were some things, obviously, that might have been a little frustrating for new contributors. Was there anything else in particular that kind of was tricky to work around just because you were that first outside contributor?
The Slack channel they work in is really quiet and really hard to get any responses out of. So like if you have a question about something or you want to know their preferences on something, you'll probably have to wait a couple days. I mean, they all have full-time positions, right? It's not their first priority. So that's a little difficult. And then yeah, it's just a lot of problems with their documentation, but that's fixable.
Gotcha. That's pretty interesting. And I'm sure that's that documentation is probably some of the most valuable, going forward.
Yeah.
It's awesome. Great job.
Thanks.
Any other questions? Because I believe, yep, that was our last. And we're actually 10 minutes early here. So one final call for questions. And yeah, as we wait for those, thank you everyone for sticking around to the end here. Pretty awesome presentations today. And of course, welcome to all those new first-time RCOS members. We hope you enjoyed your semester and stick around. If that's it, if you didn't get the attendance in, just message a coordinator on Discord. But otherwise, we will see everyone next meeting. Have a great weekend.